To start the next section, we need to remind ourselves of the properties of exponents that you learned in Algebra 1. So take a look at the product of powers, the power of a product, and the power of a power. We can see here that when we multiply the same base with different exponents, we can add the exponents. When we multiply different bases to the same exponent, we can bring the exponent into both. And when we take a to the m and raise it to another power, we can multiply the exponents. We can also see the quotient of powers, where we subtract the exponents, the power of a quotient, where we can distribute the exponent, and the negative exponent, which we talked about in the last section. So we want to do these practice problems to evaluate the expression. We have negative 9 to the 0 power. That's going to equal 1. Because if we look at the 0 exponent here, anything to the 0 power equals 1. Negative 8 to the negative first will be negative 1 over 8 to the first. And 4 to the negative 3 will be 1 over 4 to the third, which is the same thing as 1 over 64. And then here, 5 to the 0 power, we know, is 1, so I have negative 1 on top. And 3 to the negative 2 means we bring that up to the top. So I would have negative 1 times 3 squared, which is just going to be negative 9. So in class tomorrow, we'll look at 5 through 12, and you can use the practice problems 1 through 4 and the properties to help you solve those. 1 through 16. Now look at example 1 for 5.2. The directions are use the properties of rational exponents to simplify the expression. So even though we have fraction exponents, we can do the same thing from the properties that we learned in Algebra 1. So 7 to the 1/4 power times 7 to the 1/2 power will just be 7 to the 1/4 plus 1/2. And if we add those fractions together, we get 7 to the 3/4. And we don't need to solve that. We can leave the answer just like that. Part B, we have 6 to the 1/2 times 4 to the 1/3 all squared. So we can distribute this 2 exponent into both. So we get 6 to the 1/2 times 2 times 4 to the 1/3 times 2. And then if we simplify that, we can get 6 to the first times 4 to the 2/3. And there's a few different ways we can solve part C. One way that your book is going to show us is if we have 4 to the 5th times 3 to the 5th, we can take these two numbers and make it 4 times 3 to the 5th. And then raise that to the negative 1/5. So from here, we can multiply the 4 and 3 to get 12. And then we can also multiply 5 times negative 1/5. In our exponent. When we do this, think about what we're going to get. (12 to the negative first power). Yeah. And that's going to equal 1 over 12 to the first. So just 1/12. Looking at part D, I'm going to say this is 5 to the first over 5 to the 1/3. So 1 minus 1/3 is going to be my exponent. I'm running out of room here. So this would just be 5 to the, let's see, 1 minus 1/3 is 2/3. And that would be our final answer there. Part E, we can take the squared and take the 1/3. And multiply the 2, because we have 42/6 to the 1/3 power, because the whole thing is to the 1/3. And then we can raise that to the second power, because then that whole thing is squared. So now 42 divided by 6, that's 7. And then to the 1/3 times 2 gives us 7 to the 2/3 power. And that's how we solve the problems for example 1 using properties of rational exponents.